I've spent a lot of time on creating videos to understand the Ethereum blockchain. I think I now have a reasonable idea on what the blockchain is. We have an idea on how to create accounts using MetaMask and how to transfer money between people. Now, this is the topic that is going to dominate the rest of my videos, and that is a smart contract. Smart contracts are what we use to build interesting applications on the Ethereum blockchain. And it's going to be a lot of fun because I'm going to make a lot of interesting apps. I'm going to start off with this plain English definition of a smart contract. Right now, imagine a smart contract as being an account. And actually, first of all, so a smart contract is an account controlled by code, right? And so imagine a smart contract as being an account similar to what I created earlier on the R.I.S.E network, but rather than being controlled by humans, it's controlled by code. And this code that a developer like you and me are going to author. And so this code instructs the smart contract how to behave. So let's talk about the different properties that are contained in a smart contract account. So I'll pull up another diagram. And I'll go ahead and share that diagram. All right. And try to resize this so you can see it. Okay. All right. So we earlier we talked about public key, the nonce, and different characteristics. And a contract account has a couple of different fields. It has a balance, which records the amount of ether. Then there is storage, where we can store data related to whatever application we're trying to build, and any type of data that's relevant to the application that we're trying to make. The next property is code. So um, every every machine level code, it has some machine level code. Is what I'm trying to say, that is impossible for you and I to read. So the code that I write will be compiled down to this raw machine code and then stored inside the contract account. So the contract account always has a good idea of what the contract is trying to do. Its code and instructions are stored along with it. So there's a last but critical difference between the account I created earlier and the contract account. So I'm going to pull up yet another diagram. All right, all right, all right. I'm going to share my screen for this one once again, and I'll resize this. All right. So earlier videos, I used MetaMask, if you recall, and this is an external account. External accounts live in their own universe and are decoupled from any individual network. I can connect via the R.I.S.E network and other networks. Um, but on the other hand, these contract accounts are only specific to one individual network and they cannot be accessed across networks. So if I have a certain amount of code inside the contract here in this account, inside the R.I.S.E network, and I wanted to access it over here on the Coven network, I would have to take this code and redeploy it to these networks over here. Okay, so I'm going to pull up yet another diagram of how we can picture these contract accounts. And here we go. And I'm going to go ahead and share my screen once again. All right. And so I'm going to author some amount of code that's going to serve as the contract source. And I'm going to take that contract code and deploy it to a network like R.I.S.E. It's going to create an instance of the contract or contract account. And I can take one contract file and deploy it to multiple networks. In that sense, you can imagine the relationship between the source code files and the deployed instances as being similar between the relationship between a class and an instance, such as in Ruby programming. It behaves in exactly the same fashion. So once again, I'll pull up another diagram. Let's see. And this will be the last diagram I pull up. And I'll share this one. All right. Make it just a little bit bigger so you guys can see. Okay. So the contract source code here would be as a class of sorts, and it's the definition of the behavior of some object, similar to in object-oriented programming in Ruby language. And that we then create instances of that class by deploying them to specific networks. Now imagine we have a class car, and for this, I think I'm gonna pull up like an Atom editor in particular. Go ahead and pull up a new file, and I'll go ahead and share this. All right. So imagine we have a class, create a class of car, just something like that, right? And there can be many instances of car, right? Or in Ruby programming, you do something like class of invoice, right? And it would have the N there. And then it might have some kind of method there, summary, something like that, right? All right. So anyway, this whole thing is not what's important. I'm just trying to give you more of a visual. So it's very similar to how I'm going to write the source code. It's going to describe how the account will behave, but to actually work with the car class, for example, I would have to create, or the invoice class, I would have to create an instance of it. And so now we were doing it in JavaScript. It would look something like const Mustang, then you do new car, right? Now, if I were doing it an instance of this Ruby class of invoice, it would look something like invoice invoice.new, right? So I want you to keep this idea of classes and instances in your head as we think about smart contracts. So that is our first taste of smart contracts. In the next video, I'm going to dive into the languages or language and tooling that I'm going to use to interact with these different contracts. So stay tuned for that.